Hi, this is Algebra 1, Module 4, Lesson 1. This is the practice problems. I just want to go through a couple of these to help make sure you are on track on how to do the graphing. Very important as we're going forward. So to start with, it says graph the following equations and determine if the given point is a solution to the equation. So we're going to start by graphing these lines. And so right here, our -2 is our y-intercept. These are all in y equals mx plus b form. So this is our plus b, a -2. So I'm going to start on my y-intercept at -2. Now my slope is a 5, which means it's 5 over 1. Up 5 over 1, right 1. So I'm going to put a dot here and go up 1, 2, 3, 4, 5 over 1. And now I'm going to do it again. Right here, up 5, 1, 2, 3, 4, 1, 2, 3, 4, 5 over 1. And notice how it's lining up. So there is enough of my graph. I could also keep going the opposite direction, 1, 2, 3, 4, 5, and go back 1 if I needed to go into the negatives. So now its question is 1 comma 3 on this line? Well, we can look and see. Yes, it looks like it's on this line. We can also do our math and say we want to know, does 5 times 1 minus 2, does it equal 3? So I put in my 1 for my x, my 3 for my y. And so 5 minus 2 is 3. So yes, this is on the point. The other type I want to do is over here on this number 3. So I'm not going to do every single one of these. I'm just going to do a few to get you started. So here, number 3, -x plus 4. So plus 4 is where I'm going to start on the y-intercept, my y-axis. But -x, we always think of, if there's not a number there, I at least have 1. So we assume it's a -1x. So I'm going to start at 4, 1, 2, 3, 4, and I'm going to go down 1 because it's negative, down 1 over 1, down 1 over 1, down 1 over 1, and just keep doing that. I'll put a spot there so I'm not doing all those lines. So hard to be accurate. Down 1 over 1, down 1 over 1, over 1. So now I've got a few lines on here. My question was 2 comma 2. So I can go over here and say 2 to 2. Doesn't look like it's on my line, but let me double check. If I do -2 plus 4, does that equal +2? Well, in this case, it actually does. So it looks like my line is just a little off with my graph on here, but my equation shows that 2 equals 2. So that would be a yes. So that's why it's always good if your graph may or may not be accurate. And so let me go ahead and erase those. Let me try again because I want my graph to match. 1, 2, 3, 1, 2, 3, 4. Notice how my lines are a little off with the copy. But if I do, oh, here's a little more accurate. There we go. Yeah, so now it shows 2 comma 2 on there. Okay, one more. This one doesn't have the plus b, so I just want to make sure we're solid on how we do this. So if there's no plus b, then that must be a plus 0. It's adding nothing, so I'm going to start at 0. -4/3, it's my rise over run, so I'm going to go down 4 over 3. So I'm going to start at 0, 0, and go down 4, 1, 2, 3, 4, then to the right 3, 1, 2, 3. And try to be as accurate as possible since we have to check a point. do it one more time. 1, 2, 3, 4, down. 1, 2, 3, over. Okay? And now I'm going to look and see if 2 comma -5 is on my line. Well, there's 2, and it looks like it crosses at -3, not -5. So it looks like a no for my graph, but let's double check. Negative, oh, wrong thing. So -4/3 times 2, I'm going to go 2 over 1, because that would make it easier. Does it equal 5? Well, -4 times -2 is -8. 3 times 1 is 3. Is 8 divided by 3 going to equal 5? It is not. So this one would be a no. It is not on my line. So you still have to do the others, but that gives you a little example of how you're doing that. So the next type, we're just seeing if these are equivalent. So again, I'm just going to do one to show you how to start it. Basically rearrange on here. Maybe I'll do two. So I'm looking at 14 minus 3a plus 2. Well, let's go ahead and distribute. Let's get the parentheses out of there and just see if these match. So it's 14 minus, if I distribute the negative to each of these, it's negative 3a minus 2. Well, now notice that matches that. So are they equivalent? Yes. And I just proved my reasoning. The other one I'm going to show is 10. So again, we have parentheses in here. So let's just see what we end up with. To get rid of those parentheses, I need to distribute my 3 to both of those. So I end up with 3w minus 27 divided by 5. Now, is that the same thing as 3w over 5 minus 27? Can I just scoot the 5 over and put it under the 3? No. The proper way of writing this, if you're going to distribute the 5, is 3w over 5 minus 27 over 5. So are these equal? No. So this would be a no. So then I'll let you leave you to try the other two on here. All right. 12, you're just looking for the two that are equivalent. Same idea as what we just did. Simplify it down, see which two actually equal each other. 13, 14, and 15. Let's go ahead and we'll do one of them. Let's do 14. So 4, we need to distribute our 4 to both numbers. So we end up with 4x over 5. Notice it just, if you do a multiply, it only applies to one of them. It's 4 over 1 times x over 5. So it's 4x minus over 5 minus 4 times 2, which is 8, equals 20. Well, I want to undo this minus 8, so I'm going to add 8 to both sides. So I get 4x over 5 equals 28. Well, I'm still trying to get that x by itself, so I can try it in 2 moves or I can try it in 1 move. I could start by multiplying by 5 to both sides and then dividing by 4, or I could do it in one step and multiply by 5/4. So I can multiply by the reciprocal and just get it gone in one shot. So those two would cancel, leaving me my x. 28 times 5. Let's see. Do I know that off the top of my head? Well, here, let's simplify. 28 divided by 4 is 7. There we go. 7 times 5 is 35. So in this case, my x equals 35 for number 14. So just wanted to show you how you can do that division in one step when it's a fraction over here with the x. All right, last ones. Let's look at 16 through 21. These are basically asking, they give you a solution right here, and they're saying, does it work in here? If I plug in -3 for a, do I get an answer of -9? Yes or no? So got to show your work on here. So I'm going to put in 4 times -3 plus 3. Does it equal -9? Well, that's -12 plus 3. Yes, -12 plus 3 is um, -9. Now let's jump over here to 19, where it's a little more complicated looking. So z is -5. So I'm just going to go ahead and plug in the -5 and use my order of operations to check this one. So 2 times 5 minus 2 times -5, does it equal 20 minus 2 times -5 minus 1? Well, negative 2 times -5 is -10. So 5 minus a -10 is actually a 5 plus 10. So I'm going to go 2 times 5 plus 10. Does that equal 20 minus, so a -5 minus 1 is a -6, right? 2 times -6. Run out of space here, so I'm just going to ignore this one at the moment. So now I have 2 times 15. Does that equal 20 minus, and it's -2 times a -6. So that'd actually be a positive 12. So in this case, 2 times 15 is 30. Does that equal 32? It does not. So this one would be a no. So there's how you can substitute in and be able to solve those. So I'll leave the rest for you guys to try on your own. Thanks for joining, and we'll see you next time.